Hello everyone. So now we'll see the rotating magnetic field. Okay. So from this figure you can see there it's a three-phase supply and it's having the 3 points like R, Y and B. Okay. And one more point is there, that is a neutral point. So usually we say that three-phase is nothing but it's having the phase difference of 120 degree. Okay. So the point SA, SB and SC. So these are the starting points which are connected with respect to R, Y, B point. And FA, FB, FC. So these are connected to the neutral points. So in 11.5 figure you can see the graph. So you have three flux, that is phi A, phi B and phi C. So in first condition it's starting with the origin. So you have the phi A equation will be the phi m into sine of omega t, because there will be no leading or lagging chances. So in second condition, that is phi B, you can see it's lagging, like phi m sine omega t minus 120 degree. Why 120 degree? Means three phase means it should be having the phase difference of 120 degree. Okay. If you see the third one, that is phi C, so that is phi m sine omega t minus 240. Okay. You can write minus 240 also, or you can write plus 120 also. Both are same. Okay. So these are about the three equations. You should remember these equations because we need to see the rotation of magnetic field with respect to different angles. Okay. So here we'll see with respect to 0 degree, 60, then 120 and then 180. Okay. So first one we'll see with respect to theta is equal to 0. So here omega t is nothing but your theta. Okay. Omega t is equal to theta value. So theta value, whatever the angle is given, you can substitute that with respect to omega t. Okay. So when you put theta is equal to 0 in first equation, that is sine of 0. So it becomes phi A angle is 0. When you put phi B sine omega t minus 120, instead of omega t you put it as 0. So sine 1 minus 120, it should be minus root 3 by 2. So when you put sine of plus 120, so that will be your plus root 3 by 2 into phi m. So when you put with respect to theta is equal to, that is omega t is equal to 0, so you are getting these three values, that phi is equal to 0, phi b is equal to minus root 3 by 2 into phi m, and phi c is equal to root 3 by 2 into phi m. Okay. So one more thing we have, that is resultant flux, that is phi r is equal to 1.5 into phi m. Okay, it will be remains constant for everything for the rotation of the magnetic field. Okay. So initially phi is equal to 0. So if you see the 11.7 figure, so it's 0. So there is no notation of phi a because it starts with the origin. And next see the phi b. Phi b is given with respect to 30 degree, that is minus root 3 by 2. And similarly phi c. Okay. So now we'll see the second condition, that is theta is equal to 60 degree. So when you put the omega t, theta is nothing but a omega t. So omega t is equal to 60 degree in these three equations. So you are getting phi is equal to root 3 by 2 into phi m, phi b is equal to minus root 3 by into phi m, and phi c is equal to 0. So here the phi c terms remains 0. So there will be no angle of phi c. So next, with respect to 60 degree, you can see first one phi b, that is root 3 by 2 into phi m. The resultant flux remains same, that is 1.5, and then the phi a, that is with respect to root 3 by 2 into phi m. So this is about with respect to 60 degree. Now we'll see with respect to theta, that is omega t is equal to 120 degree. So same, when you put this 120 value in these three equations, So you are getting phi A is equal to root 3 by 2 into phi m, but here phi B terms remains 0 and phi C becomes minus root 3 by 2 into phi m. So when you rotate it with respect to clockwise direction, so your resultant flux remains same 1.5 into phi m. So phi A value will be root 3 by 2 into phi m and phi C value will be minus root 3 by 2. Okay. So similarly, when you reach to the 180 degree, theta is equal to 180, that is omega t is equal to 180 degree. So that time it will be remains same like phi A is equal to 0, phi B is equal to root 3 by 2 into phi m and phi C is equal to minus root 3 by 2 into phi m. So here phi is equal to 0. Okay. So the three flux at the at this instant, the resultants are, you can see in that figure, it is observed that the resultant flux has rotated by another 60 degree, that is through 180 degree from its original position, and the magnitude will be 1.5 into phi m. Okay. So from this rotating magnetic field, we can conclude that, so as I said, theta is equal to omega t versus theta is equal to 0 to theta is equal to 2 pi. The resultant flux also rotates with the same angular velocity omega and having the constant magnitude of 1.5 into phi m. Therefore, when three-phase supply is given to the stator winding, a rotating magnetic field of constant magnitude 1.5 phi m and rotating with the synchronous speed ns is equal to 120 f by p is